Good morning, my dear students. Today, we're going to learn about Lesson 5.4, Electric Current. On your student book, it is on page number 78 to 79. To start with, let's do the pre-assessment. This will be an individual work. On the left side of your notebook, write the difference between complete and incomplete circuit. You have only 3 minutes to do this activity. For the learning objective of this lesson, to know that electrical current flows in a circuit. So at the end of this lesson, you will be able to know that electrical current flows in a circuit. Now, take a look at this slideshow. Power stations. Remember, a power station or a power plant is a place where electricity is produced. Those are examples of power stations or power plants. Now, the questions. What happens at the power station? Second, are power stations right next to the places that use the electricity? Third, can you explain the way electricity gets the power station to our homes? On the right side of your notebook, write the success criteria and meaning of keywords that you can see in the glossary of your book. For the success criteria, write 1 or 2 points on what you will learn at the end of the lesson. And for the keywords, you're going to find the definition of the following keywords using the glossary of your book. The keywords are flow, current, and particles. You have only 3 minutes to do this activity. Now, it's time for discussion. Watch this video carefully.
Mom, where does the electricity for my video game come from?
That's a great question. The electricity we use is delivered to us by PSEG Long Island. It comes from far away and from different kinds of power plants. For example, power plants can use coal, natural gas, or oil to make steam. Some plants use nuclear power. There are also natural sources of power from dams, hydroelectric plants, solar arrays, and wind turbines. The plants use these power sources to turn a generator that has huge magnets and wire coils inside. The magnets begin moving, generating currents of electricity in the wire. Usually power plants have several generators running at the same time that produce a lot of power. The power is transmitted at high voltage and then distributed at low voltage so that we can use it in the house. Transformers are used to raise the voltages 69,000 or 138,000 volts, which allows for more efficient transmission to substations miles away or into a network that connects to other power companies, so electricity can be shared efficiently.
Now, the question, when do we know that electricity is moving through a circuit? Can we see it? Now, for another activity, you will have think, pair, and share. Look at the image of fan on student book page 78. Work with your partner to answer the questions 1 to 3. Then write the answer in your notebook. We cannot see electricity, but we can observe its effect. The questions are, number 1, what happens to the fan when it's plugged in and switched on? Second, where does the electricity comes from to make the fan work? For number 3, describe how the electricity gets from its source to the fan. So you will answer these 3 questions. You have only 3 minutes to do this activity. Next, read through the information on student book page 78 to 79. Think about the circuits you have built. When the circuit is closed, the light bulb glows. You already know that the battery is the source of electricity in the circuit. The fact that the lamp lights up shows us that electricity has to travel from the battery along the wires and through the lamp in order to make it work. The flow of electricity through the circuit is called an electric current. We cannot see the current, so we have to use models to describe how it flows. You can think an electric current as a flow of tiny particles called electrons through the wire. If you're small enough to stand inside the wire, you would experience the current as a movement of many tiny particles flying past you. You and the particles that make up the wire would be still while the current flowed past. Look at this diagram to see one model that describes the flows of electric current. The circuit is a loop. The current travels around the circuit continuously until you break the circuit. This means that the current flows from the battery around the circuit and back to the battery. The battery acts like a pump to push electrons around the circuit. What is electrical current? An electric current is a flow of microscopic particles called electrons, flowing through wires and components. In which direction does the current flow? From the negative terminal to the positive terminal of a cell. Now, watch this video about the direction of electric current.
Alright, now's the perfect time to talk about electric circuits. An electric circuit is a closed loop where current can flow around. In this example of a flashlight, electrons can flow from the battery, through the copper wire, through the light, and through another piece of wire to the other side of the battery. Now remember, when current is flowing here, all the electrons are moving at the same time. Over here, the negative terminal of the battery is pushing the negative electrons away, and those electrons are pushing other electrons away. And this keeps happening throughout the circuit, allowing energy to be transferred from the battery to the light. But if you were to cut one of the wires here, you would no longer have a complete circuit. The electrons can't just jump through the air from one wire to another. So if electrons can't push each other around in a complete loop, no current can flow. When there's no current flowing,
That is the direction of electric current, how the electric flow in a circuit. Now, let us discuss the answers for question 1 to 4 on Student Book page 78 to 79. For number 1 question, what happens to the fan when it's plugged in and switched on? Second, where does the electricity come from to make the fan work? Number 3, describe how the electricity gets from its source to the fan. Number 4, use the diagram to explain how electric current flows around the circuit. The answers for question number 1, the blades will turn and the fan will work. For number 2, where does the electricity comes from to make the fan work? From the main supply via the wall plug. For number 3, describe how the electricity gets from its source to the fan. It is transmitted via electrical cables to the home and then through the circuits in the wall to the device itself. For number 2, use the diagram to explain how electric current flows around the circuit. The current flows from the battery around the circuit and back to the battery. For your individual work, you're going to complete the workbook activity on page 67. Modeling electric current. You're going to answer these questions. First, what is moving through the wires in a circuit? Second, what do we call a flow of electricity? Third, what is the role of the battery? Number 4, say how we know the current is flowing. Number 5, what can you do to stop the flow of electric current? Then number 6, label this diagram to show how the electrical current flows through the circuit in a flashlight. You have 5 minutes to do this individual work. do this virtual lab. Click this link and do the virtual lab activity. This is the link. What you're going to do is to construct a circuit and show how the current flows in a circuit. You have only 5 minutes to do this activity. For your assessment, click this link and do the online quiz. This is the link. And now, for your homework, scan the QR code and do the homework. This is the QR code. That's all for today. Thank you for listening and have a good day.